Hello guys, and welcome to this new tutorial where I'm going to show you how to use the amazing library named as Snap7. Snap7 is a library which allows to communicate between S7 PLC Simatic family Siemens with another device. In this case I use my PC as client. First of all, you have to go in this website here, snapsourceforce.net. You can find here all of the information you need to develop your software and also download the fantastic library. This library is written by my good friend, Dave Nardella. You can find Dave Nardella everywhere in the web, don't worry. So practically what I want to do is to use this configuration. I have a really PLC now connected. This configuration is in IM, and I have a client. I use my PC under Windows 7 and Visual Studio. You can find attached to the download. You can find also some basic project, and start to use it, and develop over it. In my case, I have this project. Maybe next month I have to start up and start the commissioning, and I want to simulate before to go inside. Very easy. I have deleted all of the devices, no need for this simulation. For the simulation I got only the CPU. This is a CPU. Inside the CPU, PNIO, you can find here where to set the IP address. This is the mask for a local net. And I have also a router. I use the router in my office here also. You will find what to do if you want to connect to the PC and also stay connected online. This is the net for the PLC, in this case automation net, and this is also DNS if you want to go over internet. This address is the router address inside the router. Okay, let's start. This is the CPU. First of all, you have to compile and then download into the PLC. Operation very easy for programmer of PLC. I hope to start. Now the net is searching for the PLC. Maybe 1 hour to find it. This is the address PLC, loading, okay, yes, let's start. Warm, restart. Hardware configuration need to download into the PLC. In this case, I have already installed and downloaded some file. For example, I use this FC to write back what I receive from the PC. I write back. Not here, maybe here. This is my logic I use in this case for the communication. I reserve 2 data block for TX. This data block is data the PLC send to the PC, and this one is RX, what I receive from the client. Okay, this is our data. Okay. But for this job, I create also 2 watt variable table. This is what I send to the PC, and this is what I receive, in this case here. Now I am online already. What to say about Visual Studio? Very easy. When you download the library, you have also some project inside. In my case, I copy the base of the client and I develop over it. In this case, I create my object, you see, constructor, different constructor. This is my object for this installation. I create also 2 classes, data incoming and data outgoing. Here, very easy. I wrote this public method, get item by name, for example, because I want to get all of the item. This item I want to get it from directly from the collection. So practically, what about the form? This is the form. This is my window. I can see when I launch this application. So here I have the address of the PLC, rec, slot, connect and disconnect. DB read. This is one shot reading where here to this DB 701. How many bytes? 176. This is for section. This is for the writing. I write where here. You see here. I write here. Okay. I can write also continuously, read and write. This function I made if I want to read and write. So practically I write and immediately read the feedback. These are some data. For example, item, ID, destination, data 1, data 2 for general purpose, and here some flag boolean for this particular installation. Practically I design my protocol. This is what I receive from the PLC inside the PC. This is what I send to the PC. Here you have, in the fantastic library, you have also a wrapper. What does it mean, wrapper? Wrapper is a special function which works for you. For example, the low-level library, you cannot see here inside, use byte. Send every time you communicate in somewhere on some device with some devices, you send and receive byte. But in my application, I need string, I need chars, I need double integer, I need flag, I need integer, different kind of data. This wrapper provide for you to transform and provide data already done to be used. For example, now I start. This is the application. I connect to this because, if you remember, this is the address of the PLC, rec, slot, depending by the type of kind of the PLC, because we can connect and we can exchange data between client. This is the configuration. For example, my PC now is a client. I send a request, reply. This is a PLC. Inside of it, we have the CPU, communication processor, memory, CPU, and automatically, without configure any other things, for example, NetPro, do you remember in the past, if you want to communicate with the generic device as a PC, you have to create here a communication link, but now, no need. With this library, you don't have to design nothing inside the NetPro, and you don't have to use no library low level in Semantic Snap7. No TCON, no T-receive, nothing. Practically, you decide which data block you want to use for your exchanging data. For example, you receive here. Okay, this is an UDT, user data defined type. You receive here and you send here, and you synchronize by using the new message here, nuovo messaggio in Italian language is new message. Practically you write all of data you need and then you set one through this to synchronize. And the other side, when this one is true, and also in the PLC, it means that the data are valid. For example, here, if I remember well, but I don't remember well, I know because my brain is old. Oh, practically here, not here. Vabbè, insomma, no, ci siamo persi via. RX, for example, in the RX PLC, you see when I have this array is identifier of a special item. When I get a new message and I have this one to be sure the information is reserved for this item in my installation, I make my operation and reset here, set to 0 this value, because every time PLC running, looping, and then for each one scan, check this one. Okay? Connection is okay. I am connected already. I want to write something here. Let's check. This is what I receive inside my PLC. This is what I send. For example, I want to send for this item ID 555, destination 2, data 1 25, 36, LU, load unit presence, priority. First of all, I have to simulate the logic, accept all of them, accept manually, and I send data. You can see here now data change for this item. Okay, you see, very fast. Data, item ID, 2, destination, data 1, data 2, UDC present, acknowledge, okay, accept. You can see here, acknowledge. In this case, I can continue read the cycle by using the timer, but if I want to immediately read, I put this one, I send data, I change data, for example now 233, destination 1, data 1 10, accept here. When I push db write, automatically I read back. You see, this is what I write, and this is what I read from the PLC. Very fast, no confusion, no function inside the PLC. This is very good library. I hope this tutorial helped you to use this fantastic library. Dave Nardella is automation and information technology engineer from Italy. We are very lucky to have many people like him. We want to develop and we want to be useful for this library from Italy, guys, from Italy. See you in the next tutorial.